myself, Rajendra Sparale. My qualification is MSc Chemistry BEd and experience is of 28 years. Now, today we are going to discuss about valence bond approach of covalent bond. Now, two important theories. Based on quantum mechanical principle are used to overcome these limitations of octet rule, that is formation of covalent bond and Vesper theory. The first theory is valence bond theory, which is also called as VBT, and second theory is molecular orbital theory, which is also called as MOT. Now listen here. Two important theories based on quantum mechanical principle are used to overcome the limitations of octet rule. That is your formation of covalent bond and Vesper theory. These two important theories are valence bond theory, which is also called as VBT, and second theory is that molecular orbital theory, which is also called as MOT. Now first we'll discuss about valence bond theory, which is also called as atomic orbital theory. VBT. Now here valence bond theory or VBT, it is based on number one, knowledge of atomic orbital, Number 2, electronic configuration of an element. Number 3, overlap criteria of atomic orbital and number 4, stability of molecule. Now this valence bond theory it was first put forward by Hitler and London in 1927 to explain the formation of covalent bond in hydrogen molecule. Now it was extended by Pauling and J.C. Slater in 1931 to explain the geometry of molecule. Now listen here. Valence bond theory was first put forward by Hitler and London in 1927 to explain formation of covalent bond in hydrogen molecule. This theory was extended by Pauling and J.C. Slater in 1931 to explain the geometry of molecule. Now here write down postulates. Number 1, a covalent bond is formed only when half-filled atomic orbital of one atom half-filled valence atomic orbital of one atom overlap with half-filled valence atomic orbital of other atom. A covalent bond is formed only when half-filled valence atomic orbital of one atom overlap with half-filled valence atomic orbital of another atom. Second condition is that, second postulates the atomic orbital having unpaired electron in the valence shell can take part in overlapping. Third postulate, the valence electron have nearly the same energy are involved in the formation of covalent bond. Then next, the spin of unpaired electron in the valence shell, involved in the formation of covalent bond should be opposite to each other. Then next, the pairing of electrons takes place in the formation of covalent bond. Then the spin of electrons are neutralized during the pairing of electrons. Then next, complete overlapping of valence atomic orbital is not possible due to force of repulsion between nuclei of two atoms. That means here complete overlapping of valence atomic orbital is not possible due to force of repulsion between nuclei of two atoms. That means nucleus contains proton and neutron. Proton carries unit positive charge and neutrons are electrically neutral. That means here nucleus carries positive charge. That means when two atoms comes closer to each other, the nuclei of two atoms repel each other because they carry positive charge. Then next, the electron density between the two nuclei during the process of overlapping of valence atomic orbital increases. It causes decrease in force of repulsion between two nuclei and an increase in force of attraction between the nuclei and the electrons. Hence, an energy of the system decreases and a stable covalent bond is formed. The internuclear distance at which force of attraction balances the force of repulsion called as is called as bond length and the energy release is called as bond energy. The internuclear distance means distance between two nuclei. When force of attraction balances the force of repulsion is nothing but the bond energy, bond length and the amount of energy released. When force of attraction balances the force of repulsion is called as bond energy. Now here, next number. The strength of a covalent bond depend upon the extent of overlapping greater the extent of overlapping of valence atomic orbital stronger is the covalent bond and vice versa. Now we have the number of covalent bond formed is equal to the number of half filled valence atomic orbital that means your number of unpaired electron present in an atom Now here covalent bond form possess directional character. This is because each atomic orbital p, d and f except s has a particular direction in space. Now then next, geometry of a molecule depend upon the directional overlap orientation of valence atomic orbital. Now here atoms do not lose their identity after the formation of molecule. Now here draw the diagram. This is half filled valence atomic orbital of one atom and this is half filled valence atomic orbital of other atom. This is the overlapping region, and here bond which is formed here is nothing but the covalent bond. That means here force of attraction balances the force of repulsion, and this distance between two nuclei, which is also called as bond length, this distance is also called as interatomic distance. That means here bond length is nothing but the internuclear distance. Internuclear bond length is nothing but the internuclear distance. That means distance between two nuclei where the force of attraction balances the force of repulsion. Now, amount of energy released during the formation of covalent bond is nothing but the bond energy. That is, bond energy is nothing but the amount of energy released when force of attraction balances the force of repulsion. Now, by using this diagram, you can easily keep in mind the various postulates of valence bond theory, which is also called as atomic orbital theory. Suppose you want to learn the first postulates. By using this diagram, you can easily construct a covalent bond is formed only when half-filled valence atomic orbital of one atom overlap with half-filled valence atomic orbital of another atom. Now, second, the atomic orbital having unpaired electron can take part in the process of overlapping. Now, third, the valence shell electron should have nearly same energy. That means in this way you can easily learn the various postulates of valence bond theory on the basis of this diagram. Now here, one postulate is given in the valence bond theory. That means number of covalent bond form is equal to the number of half-filled atomic orbital or number of unpaired electron present in the atom. Suppose you can consider the molecule that is F2. The electronic configuration, that means EC of F is 1s2, 2s2, 2p5, that means 2ph2, 2py2 and 2pz1. That means fluorine atom have only one unpaired electron, which is present in the 2pz atomic orbital, or fluorine have only one half-filled atomic orbital. That means single bond is exist in between two fluorine atoms. In a similar manner, you can calculate in O2, that is oxygen, EC of oxygen, that is 1s2, 2s2, 2p4, that is 2p x2, 2p y1 and 2p z1. Now, oxygen atom have two unpaired electrons. One is present in 2py and other one is present in 2pz. Or oxygen atom have two half-filled atomic orbital. Therefore, oxygen atom form two covalent bond in between two oxygen atoms. In a similar manner, N2 EC of nitrogen is 1s2, 2s2, 2p3, that is your 2px1, 2py1 and 2pz1. That means here nitrogen atom have three unpaired electrons present in 2px, 2py and 2pz, or nitrogen atom have three half-filled atomic orbital. Therefore, nitrogen atom form three covalent bond. Now the most important postulates of valence theory is that valence bond theory is that a covalent bond is formed only when half-filled valence atomic orbital of one atom overlap with half-filled valence atomic orbital of another atom. Second, the strength of covalent bond depend upon the extent of overlapping. Greater the extent of overlapping, stronger is the covalent bond. Third, the number of covalent bond formed is equal to the number of half-filled atomic orbital or number of unpaired electrons present in the atom. Now, one most important postulate is that the electron density between the two nuclei during the process of overlapping of atomic orbital increases. That means it causes decrease in the force of repulsion between two nuclei and an increasing force of attraction between nuclei and electron. That means energy of the system goes on decreases and the stable covalent bond is formed. The internuclear distance, which balances the force of attraction and force of repulsion, is called as bond length, and the amount of energy released during the process is called as bond energy. Now, this is regarding about valence bond theory and their postulates, and the remaining part of this unit will be discussed in the next lecture.